Good morning, everybody. Welcome to the webinar, Smart Data Lakes for Life Sciences. My name is Raj Tekchandani, and I'm the Director of Marketing here at Cambridge Semantics. And I'd like to thank you all for taking the time to be with us today. I hope you will find today's session very informative and well worth your time. The big data era is forcing life sciences organizations to rethink how to best prepare, manage, and analyze their diverse R&D data at scale. The current approaches like a rigid relational data warehouse or an unwieldy Hadoop-only data lake are all ill-equipped to provide R&D insights required by clinical ops, data management, and safety and pharmacovigilance groups. There has got to be a better way. As you learned today, Anzo Smart Data Lake delivers unprecedented data value, turning critical and highly sensitive R&D data assets into extreme insight and competitive advantage. Our panelist for today's discussion is Jim Lapointe from Cambridge Semantics. Jim is the Managing Director for Life Sciences at Cambridge Semantics, where he helps life sciences customers utilize the transformational power of semantic web technologies embodied in suite Anzo Smart Data Platform and Anzo Smart Data Lake software products. Prior to joining Cambridge Semantics, he has been an exceptional business leader and IT visionary with vast experiences building IT-oriented companies and directing enterprise IT strategies, IT operations, application portfolio management, application development integration, post-development application support and maintenance operations in a diverse range of industries, including life sciences, healthcare, financial services, consumer products, energy, and communications. Just before we start, a quick note on the logistics. The session will be run about 50 minutes, and Jim will answer as many questions as possible at the end of the session. We will be making the slides from today's webinar available on our website in the coming weeks. If you have topics you'd like to learn more about in the future, please get in touch with us. If you have a question for Jim, please type it in the questions panel in the webinar software. Please feel free to use the questions panel also if you have any troubles with the webinar, have any questions not related directly to the webinars as well. Without further ado, I will pass it on to Jim. Jim, take it on.
Good morning and good afternoon. Thank you for joining us today. What we'd like to do is spend the next 45 to 50 minutes going through this emerging and exciting technology called Smart Data Lakes. And I hope that you'll find the application to the kind of issues that we're being confronted today in the life sciences industry. Just jumping in right away, here's an example of a use case that we're going to talk a little bit about today. What you're actually looking at here are two different compounds. One of them on the left is the standard of care today, and the compound on the right is the investigative product. And what you're looking at is an analysis. Basically, this is a meta-analysis across multiple clinical trials. And this is something that we were able to bring together in less than about 4 weeks, and to try to look at and analyze this kind of data. The power of the platform and the techniques used to bring this integrated data and the visualizations together are really what this next 45 minutes is all about. We'll revisit this use case in a little more detail as we go forward, but I just wanted to show you a little bit of what we're in for and the kind of analyses that are possible with this technology. So a little bit about Cambridge Semantics. We're an 8-year-old company. We're a software company and the creators of the Anzo Smart Data Lake. We've been perfecting this technology over the last 13 years. Like I said, 8 years here at Cambridge Semantics. Many of our founders had been working on this technology in an IBM research center for 5 years prior to that. You'll see also that our technology is maturing at a rapid rate. We're in our 4th generation of the implementation. You'll also see just some names of the customers that we have in the life sciences space. We also work in the financial services, government sectors, but the life sciences area is our largest and most varied vertical. So we also have a number of technology partners that you'll see down below, like Linguimatics or Sightline, and we have some consulting partners that help deliver our platform to some of our customers. We're also the proud owners of many software awards, the Cody Award, Best in Show at BioIT World, and if you've ever been to any of those conferences, you may have met us there, or if you go to one of those conferences, look for us. One of the things I wanted to do is just sort of start at the beginning, right? So here at Cambridge Semantics, we believe that your data will change the world, right? So data all by itself is just not enough, right? So obviously we need to do something with that, and that's what our company is all about. We're taking your data and putting it in the hands of the right people at the right time to generate the right insights. If we look across the life sciences industry, there's many things that can happen, and how do we view how your data will change the world, right? So there can be innovative therapies, or improved patient outcomes, or speeding the regulatory process, or reducing compliance risk. All of these are kind of different areas within life sciences. There are many others. Each industry has their own. So data can address a lot of these kinds of problems, and I'm sure that you're dealing with those today. Today, I want to spend a little bit more details as to how actually that happens, right? So at Cambridge Semantics, we take your data and we turn it, and we believe we make it smart. And the way we do that, and we'll define a little bit more what smart data is in our world, but we call smart data linked and contextualized. Now, linked is pretty obvious. You can bring data together from diverse sources and bring it and basically integrate it in things in the challenges that we've had for years to try to integrate data. Contextualizing is a little harder to sort of conceptualize, right? So contextualized data means it's relatable to each other, and it's put in sort of appropriate categories, and I'll show some examples of that in a minute. To sort of bring that to more of a practical view, I'm going to actually cover 4 use cases that we've worked on, and they involve in different areas. So we'll talk a little bit about clinical trial data integration and discovery, right? So sort of related to those innovative new therapies. We'll show an example of the clinical trial site selection and optimization, and we'll actually show a demo of the platform quickly in that space. There's a PV and safety data management use case, and then we'll basically highlight some of the unstructured capabilities of this, and it'll become more obvious what unstructured means. And then later on, we'll talk about where this is all going in real-world evidence-driven clinical trials. So we'll cover those 4 use cases. We hope that some of them resonate with you, or it spawns some thinking about the kind of challenges that you're confronting. So let's look at what smart data is. So if you think about our current state of our technology, we have a lot of relational data. We call that structured data. So let's assume that this is some SQL database of some kind. And what we can do is we can take this information and we can put it in a graph structure. So we'll actually take this structure and take basically the schema, so we know that the column 1 is the company, column 2 is a website, column 3 is the market cap, and represent that in a graph structure. There's a couple of benefits for doing that. One of them is that company now is inherently defined as an entity within our graph. So that's what we mean by contextualized, right? If the schema for the relational database disappeared or was changed, then we would have to go back to our whole table structure and make changes to it. In a graph database, that's not necessary, right? So the entity company and the edges or the relationships like name, market cap, and website are captured within the graph. It's forever related to the values within the graph. So the company name, drugs 1, 2, 3 are all represented within the graph database, right? And that's what we mean by contextualize. It's now viewed in context with all of the other items, and it's captured within the database structure itself. Now let's look at some diverse source of data. In this case, let's look at some web news. We're always bombarded by more information every day coming from unstructured sources, and in fact, Gartner characterizes a lot of our unstructured data in either Word documents or PDFs, web, Facebook, blogs, and those types of things as unstructured. We have the ability to ingest that data, and what we do is we pass that information through a set of text analytic engines, and we annotate the data so that we can actually find what is the context within that data. So in this web news, we actually see drugs, the drug 123 company in there, but what it also has given us is some additional information. So in this web news, we find that Drugs 123 has announced a phase 1 development project for in a new therapeutic area, or in a therapeutic area for sleep aids, and a new drug that they've termed narcoleptal. How we relate this to prior information is in our graph structure below. So we've added an activity off of the entity company called drug development, and we've added the various pieces. So this in drug develop, there's a developing drug called for narcoleptal in an indication with insomnia. Again, we've now contextualized this information. Not only have we integrated it, but we integrated it in the right places, right? So we've linked this data in. It's now related to the company Drugs 123 and is kept in context. So not only we've integrated this data or linked it, we've contextualized it, right? We can take this actually a little bit further. There are, internal systems. Let's take an example of, say, some CRM system there that somebody actually is looking at. They see that, oh, I'm looking at narcoleptal, and I want to add some notes to this as I'm looking at it. So you have the potentially to manually curate this information. So somebody's added their note saying that the safety signals look promising on this. Again, we've appended this to the graph database, and it allows us to go and expand the information, and all this information we now know about this Drugs 123 company and their drug development narcoleptal. It's all kept in context in a graph database. Okay. One of the things that we'll do, and we'll talk about it here in a second, is that we relate, and since this is a different data structure, a graph database is actually a very efficient mechanism because there's only really 3 things that we need to keep track of. Right here, I'm showing, in this case, what we call a triple. There's an entity, a relationship, and an entity. We have a highly optimized graph structure that allows us to go at very, very large scales of data and efficiently search and query this structure without having to do some really, some of those really processing intensive sort of joins and bindings for various data structures. We can also have different kinds of triples. I can have 2 edges or 2 relationships in an entity, or I can have a value in an entity. So there's different kinds of relationships. However, I just wanted to show this is the way we count triples within or the size of the data structure. And we now can do millions and billions of these in our data structures. And we're all leveraging, as I said earlier, this technology has evolved over the last 15 or so years, and we're leveraging some data that was designed, or some standards that was designed for large-scale problems, primarily across the World Wide Web. The World Wide Web Consortium came up with a series of different standards to sort of deal with web semantics, right? So the different structures that we use and support are basically standards-based and allows us to interoperate with multiple sort of partners and an emerging ecosystem of technologies providers in this space. So you'll see that the actual structure ourselves, the graph database, is stored in what's called RDF. That's an industry standard for that. As the models get more and more complex, and you can imagine they get fairly large, that the ability to sort of look at it, and we'll show you one here in a minute, as to how the ontology can be looked at, it can be expanded, it can be changed. And so there's a modeling language for that called OWL, the Web Ontology Language. And we have an industry standard query capability called Sparkle, right? So these are sort of the underpinnings of our platform, and it allows us, like I said, to be interoperable with the growing ecosystem of technology partners. A lot of industry folks are now starting to leverage these standards, so you'll see different kinds of standards coming from, say, organizations like CDIS or some taxonomies like MEDRA that are actually RDF-based, and they know that semantics allows some flexibility, and we'll get into some of the benefits of that shortly. So our platform is designed to, the Anzo Smart Data Platform allows us to take these very diverse data sets. Some of them are structured, like SQL database or Excel. Some of them are unstructured, like PDF or Word or even blogs or Facebook, or even large data or big data like Hadoop or subscription data like Sightline, right? And we bring all of that diverse data together in our platform. And you can view that sort of as a middle layer. And what our platform allows us to do natively is to provide the visualizations like you saw that I led in with. So the whole platform and stack is an end-to-end stack that it provides for the ingestion of data through various connectors. The organization, cataloging, the contextualizing and linking of that data, and actually the visualizations and dashboards and the analytics to really get at the insights that you're looking for out of your data. So as you look at the kind of things, we start with the model. I'll show you a more, when I get into the demo, I'll show you a little bit more of what the model looks like. And it allows us to drive these analytics from the model directly, right? So in this case, we have various nodes within the ontology that are providing us details, various properties and values out of those properties that allow us to do the analytics. And we'll see that in the demo shortly. Now, we are seeing many more problems where there's obviously the data scales are increasing, the volume of data and the velocity of data is increasing. So what we've have done, we've evolved our technology to sort of break up the various processing engines necessary to ingest data, link it, and provide analytics on it. So we actually have a technology stack that allows that to happen. So as you view this from at the bottom of your various data sources, or what we call the company's information fabric, we have the ingestion capability to bring in this data into actually what we would term as the data lake, right? So there's a cataloging and indexing server there. So the data is ingested through various connectors through the Smart Data Integration server. It's linked and contextualized, cataloged, and managed within the Smart Data Lake server, and that's actually the data lake. We then take subsets of that data into an analytics engine called the Graph Query Engine. It's multi-node. It's the ability to provide real-time analytics on that, and I'll show you again in the details example that we're going to go through or in the demo how that actually looks. And once we have the various dashboards and visualizations that we would use, we can store those, and we can serve that up into the general population that would like to consume either a dashboard or a visualization through either Anzo on the web or through some other mechanism through a website. So that's what we call insight realization. So we see that you can get many very interesting and sophisticated sort of visualizations, analytics like I showed earlier, and then you could provide that to your teams in general through various mechanisms. And we have full access control at all the layers, so whether data gets ingested, who's allowed to view various pieces of that, what analytics can be served, are all controlled by either role-based or specific named user-based security. So what we're now seeing, and if you look at this graph, sort of the analytics data memory on the left, and it's in gigabytes, right? So you can see it on the left. we're up at, maybe 1 terabyte of data, and we're growing from there. We start, there are a lot of proof of concepts that start pretty small, like, 2.5 gigabytes, and grow up to 25 to 250 gigabytes. In our world, we actually measure what we call active triples from an analysis standpoint. So in our world right now, we would be viewing sort of a production version of this in the 10 billion triples range. So if you think about that graph structure I showed in that brief example, that entity, relationship and entity, that single triple, we're now pushing up into production versions of that in the 10 billion triples range. And we now see problems that are now starting to come at us where we're actually working on the engineering to get up into the 100 billion triples range. So that allows us now to go after sort of this big data issues and getting insights out of big data, right? So we think that the platform is now there for those that are, interested in the kind of problems where they either have too much data prior, or they've ingested the data and they're not quite sure what's all in it. And there are different ways to get that information to contextualize and link your data. So let's go into some real cases, right? So let's take a look at it. I talked about 4 of these earlier on, and what makes your data, how your data could, change the world. So let's talk about these 4 use cases in particular. We have many, many use cases, and this is just a sort of a small sampling of the types of things that we've experienced in the life sciences industry. And you can see that some of them, start with clinical data standards and go all the way through taxonomy management to information landscape. But I'm going to focus the next few minutes on these 4 use cases in particular. And what I'd like to do is I'd like to start with this one first and then go right into a demonstration. So clinical trial site selection and optimization, right? It's an important aspect because we know we build beautiful protocols for our clinical trials, and then sometimes as we start trying to identify sites for this, who's been able to recruit, what key opinion leaders or principal investigators are able to go and actually, sort of recruit the patients and enroll the patients necessary to complete our trials. There's some studies out right now that less than a third of clinical trials successfully recruit and enroll enough patients to actually be performed. So it's important to get to this information. In this specific use case and in the demonstration I'm about to give, we're going to be looking at description data through one of our partners, Sightline, that's looking at global clinical trial data. We're not going to be showing any internal data of any of our customers, although the binding of those 2 data sources of the external subscription data and internal performance data of where trials were previously run, the experiences with various principal investigators and their teams, etc., are added to sort of provide you a holistic view of your trial site's performance over time and trying to optimize that in the future. So I'm going to go into this demonstration, and let's go from right here. So this is a visualization, the screen capture, and I'm going to sort of jump right now, so bear with me as I shift screen for one quick second. Sorry. Oops. I lost my connection. All right, I'm just restarting. And let's go to this. So this is a demonstration. It's a live demonstration of the data that I just showed you. This is the site selection demonstration. You're looking at Anzo on the web. It's accessing actually the Google Cloud platform. And we're looking at about 80 million triples, the records here. And this is the same screenshot that you just saw. But this is actually live now. So what we're looking at is we're looking at one of what we call a dashboard with a trellis of 4 visualizations in there. So this might be a good initial sort of site selection, sort of high-level view of all of the data which Sightline is providing across the multiple sources. In this situation, those 80 million triples are coming from 4 different sources, 4 linked data sources. Right? So in this case, we're looking at all the trials. Let's say, for instance, though, that I wanted to filter down here. So I'm just going to slide down, take this sort of dashboard and this lens, and I'm going to click on oncology, and I'm only going to go to this therapeutic area. And you can see now that we're filtering all of that data, and it's being done in a real-time fashion, all of those records. And now we've rendered this visualization with just the oncology therapeutic area. If I wanted to get a little more specific in there, and I was interested in the specific, let's say, country on where these trials are being conducted for oncology, I could click on this country filter, and again, it's going to filter down and let us see just the data that's interesting to us, and we could do drill downs from here. But these visualizations can be built by business analysts on the fly, or knowledge workers that have insights into the domain information. I'm not going to actually do that here, but I am going to go show sort of a different view of this data. Okay. And this dashboard is a little more I don't see it coming up, but let me go back. Here it comes. And so let me go back to, I'm not sure if that's coming up at the moment. All right. See that? Yeah. So let me go back to that other dashboard here. Still not up.
Probably your connection to this.
Yeah. Well, let me just go back down. I'm going to just shift lenses here. So again, what I'm going to do is I wanted to show you a little bit what's underneath the covers here, right? So before we talked about the ontology. This is actually the ontology of the demonstration that I'm giving at the moment. And what we're looking at here, what I'm about to show is this, this is where all the data sits in this sort of ontology. And you can see that this drug here, and I'm going to open up the drug class, and you can see the various properties within drug here. And again, this is that sort of that OWL modeling language that you can see the various entities and the properties within it. So when you look into the ability to create these, and what I'm going to do is that this drug here was actually not related to some other piece of data. This is actually coming from a different source. And the way we related these two pieces of information from two different sources is through this single link right here, right? So I'm going to actually go to the demonstration and create another filter and filter the dashboard based on relating some data that has actually wasn't relatable before. So let's go ahead and do that here. I'm going to go and build this filter, so I can go in here and I'm going to say create new filter. And what I'm actually going to do, and this is, I'm using this as sort of a, a super sort of user or power user view, but it's a business analyst capability that can do that. Okay, so I'm going through, and what I'm doing, and so the platform is graph aware, right? So what I'm able to do is go through and actually navigate the graph, the ontology that we just saw, and it's only bringing up the links that are available. So I'm going from drug to delivery to route to name, right? And I'm going to close this. I'm going to create that filter. And it's on the fly going to now give me a brand new view, a filter, for me to go and take a look at, taking a subset of my data. So in this case, I want to go take a look at, of all this data, I want to take a look at, let's say, the sublingual oral route of delivery. And it's going to filter down my data. So it allows you to explore and discover your data on the fly without actually having to write a SQL query, or in our case, a Sparkle query, which is being done behind the scenes. The amount of information on each one of these, it can vary, and obviously it's dependent on the data, but I'm just going to select this one trial. You can see the details here. There are lots of notes, the various who the investigators are, the sites that are being conducted. So you can capture a large amount of information, and you can surface it based on how you want to discover and explore the data. So I'm going to leave this demonstration. I'm going to go back to the presentation. And let's take a look at, so we just kind of went through our quick demo here, right? So I'm going to jump over now to a different use case. Again, same in the Anzo Smart Data Lake platform. In this case, it's a pharmacovigilance safety data management one where we had there were forms from the safety case report forms that were being submitted. There were hundreds, in some cases thousands, arriving per day, and it was difficult for the team to just sort of punch them into the safety system, and sort of had to manually curate them, right? So what we did is we went through an unstructured data ingestion process to bring that data into Anzo, right? So in the way we did that is through what we have is what's called a Anzo unstructured pipeline. It allows us to put various text analytic engines in place, either open source, third party, or proprietary ones. There's a bunch of ones that we have right out of the box. And you can put as many of these as necessary. And we're looking for specific kinds of information. In this screenshot here that I'm showing, it's also not only the setup of the text analytic engines, but it's also a monitoring process. You can imagine when you're crawling a corpus of documents from some repository, hundreds of thousands, and in some case millions of documents, you'd like to know what the status is, right? So if you're ingesting 1,000 documents, let's say an hour, you'd like to know how far along I'm going, right? And that's one of the things we can do is monitor that. But in this case here, well, by just actually going through the document, we've taken unstructured data and taken it and created structured data that we can do analytics on. So let's take a look a little bit at what we can do with this, right? So what you're looking at here is one of those case report forms, and various text analytic engines have fired off and have annotated the document, and that's what the color coding is. So you can see in the light blue, Tylenol and codeine. One of the text annotators have picked up a drug name, and we've now linked and contextualized that to the drug in this ontology. You can see some adverse events in here, hypersensitivity, edema, and dysphagia. Again, so that got linked for this record to the adverse event. And so we've taken this unstructured information, now linked and contextualized that to the ontology. It is now available to do analytics on that, just like we would anything else, right? Also, the other thing I wanted to point out here is that this annotation and highlighting of the document is retained for future referral. If you had to do basically an audit on it, you could find out. We maintain this in a separate binary store, and so that the various annotations can be shown. You can imagine if you have a document, let's say is a 1,000-page document, and we found some keywords in there for annotation, and we linked it and contextualized it. Finding where in that document can be a daunting challenge, right? So it's 1,000 pages. By using the text analytics, we can actually drive down right to that page, paragraph in Word if necessary. So the kind of analytics you can do, so it's available for us to do analytics. So this is an adverse event histogram. The counts, it's a very simple, you can see the adverse events and the reactions down across the bottom, and the counts up on the vertical axis. But this information, the counts actually came from unstructured data, and we were able to provide this information as it was coming in and pouring in almost on a daily basis. So you could create these dashboards and provide them to the right teams to sort of see this on a day in, day out basis as the data is changing. I'm going to make a note here. This was not part of this use case, but we often have a question about multi-language, right? So this happens to be a financial services use case here. But what you can see down below is that this is Mandarin down below. We can use various translation engines that are on the fly to translate translate the text and also put it through our text analytic engines and still find, convert the unstructured text into structured data that we can provide analytics for. So that can all be done in an automated fashion. We tend to recommend that you do some manual curation on that just to make sure that you're getting good translation, although the translations are getting better and better all the time. I'm going to go into the third use case here, and this was the one that we saw when I opened up the webinar, right? So this is clinical trial integration, the ability to bring in multiple clinical trials, just like a meta-analysis that we would typically have done, for years. Although instead of it taking months and sometimes longer, we can do that in literally weeks. And if once the system is set up and new trials come in, you could potentially be able to get new data in there in days, right? So the goal of this is to look at ingesting multiple clinical trial data across, compounds, potentially across the entire therapeutic area, and we can ingest it in various ways using, various structured and unstructured or semi-structured sources, either using CETA standards for SDDM or for ADAM, or even bringing in SAS kind of data. Right. So this was sort of that early on screenshot that I showed. So here we're looking, as I mentioned earlier, side-by-side comparison. Standard of care is on the left in that compound. The compound on the right is the investigative product. We're trying to look for specific differences between that. So what you're looking at here is the way this is filtered out is in the vertical axis. We're looking at, this is an oncology, these are oncology studies. We're looking at site visits horizontally and new lesion locations across the vertical axis, and we're looking to see where there's any significant differences there, and we can do drill down specifically and identify which trial, which patient record actually is driving this sort of thing, and try to find out where there's significant differences. There's literally dozens and dozens of additional visualizations that are provided in this specific example in order to find out if it's clinically significant. So, but it allows us to explore and discover the data in a very rapid fashion with business analysts. There's no coding into this in this example. There's no high-powered sort of SQL language queries behind the scenes. All of this is done with the dashboards, looking for specific data items, either finding outliers or significant data changes. The goal to add more data, and like I said before, is this is only 3 trials, but the ability to add many, many more trials, and we are and have implemented many, many more trials than that, and it sort of goes down that sort of big data scale that we talked about. The last one I want to talk about is the sort of real-world evidence one. So if you think about where we are right now, the ability to bring in clinical trial data across multiple trials, maybe an entire therapeutic area, allow us to explore that data, put it in the hands of really domain experts that are looking for specific things within that data is now possible, right? So we're actually taking that one step further. We're now taking that clinical trial data and sort of binding that to external healthcare data through electronic health records, right? And we're now starting to go down that path. And so that big data scale that we had talked about as we sort of push the envelope for the amount of triples from, sort of 10 billion triples and beyond allows us to go after these sort of real-world evidence kind of problems, and we're expecting to have some really, really interesting things to provide here. We'll present those results at a next, in a future webinar or at a conference. If you're interested in finding out more about the results of that kind of real-world evidence sort of results, we'd love to talk to you. This is a very exciting spot. I think there's a lot of interest in this area. So we'll go ahead and provide that information if you contact us, and when we're ready to sort of show you what we're finding out there in the industry. So just sort of in summary, we believe that we can deliver sort of, the breakthrough insights that, that you're looking for in your data. We do it through, what we call smart data, and I hope that I've been able to adequately explain, well, how we define what smart data is. It's linked in contextualized data. We can do it at big data scale, whether it's structured, the Oracle databases in Oracle Clinical, or whether it's in unstructured sources within repositories for electronic trial master file repositories, or getting, electronic health records from healthcare. We've now got to that big scale, big data scale, where those breakthrough insights, getting the right data into your team's hands at the right time, giving them the tools to research that data and explore the data, discover the insights that are necessary. We've R&D proven. We have 7 of the top 10 pharma biotech companies globally as customers, and that tends to grow. We work with small, medium, and large life science companies globally, and we feel that this, and it has been proven that this technology gives them the information that they need in their R&D data, and it's ready for use, right? So we're production quality. It's ready to be implemented. It can be implemented either on premises or in the cloud. We have various delivery mechanisms to provide that information to you in a rapid fashion. So through those kinds of things, we believe that your data will change the world. So give us a chance to show it to you. We'd love to sort of take a shot at a proof of concept on the problems that you're confronting today, and the information that you're looking for. If there's anything that you'd like to would like to follow up with, please feel free to contact me. My email is jtlapointe@cambridgesemantics.com. There is a very extensive description of the technology on our website, the Smart Data Lake white paper, that will go into a lot more detail than I was able to do in the short time we had today, and also provide you sort of some of the underpinnings of some of these use cases. Or if you're going to be at the Big Data and Analytics for Pharma Summit in a couple of weeks in Philadelphia, please stop by, see us. We'd be more than happy to demo anything that you saw today. I'll be there. We'll meet me, meet the rest of the team that's really driving some of these transformative capabilities within the industry. So with that, I'd like to turn it back over to Raj and maybe have some questions.
Well, thank you, Jim. That was very, very useful. So we have a bunch of questions coming in. We have only a few minutes, so I'll take as many as I can. And then be assured that if you have asked a question, we will get back to you in an email or follow up with you directly. So Jim, the first question that came to us is, how long does it take to do a data lake project?
Well, it kind of varies, right? So in a lot of cases, what people like to do, so our solutions are data driven, right? So it's all about the data. So we'll often take a sort of a proof of concept, right? So we'll get a subset of our customers' data, and typically in 4 to 6 weeks, we can get to the visualization standpoint. We have a growing set of connectors that allow us to ingest data rapidly. If we have a pre-existing connector to bring the data in, then that's pretty quick in the 4-week time frame. If it's a little, if it's a new sort of data source that we haven't seen, it can be a little bit trickier. Unstructured tends to be a little bit trickier also, only to get information out of that. So it can be as short as 4 weeks. We have pilots and production projects that typically take about 3 months, to provide that sort of full capability that you were seeing in some of these here. So, it's definitely not a year. It's not 9 months or 18 months or 36 months, but definitely within 3 to 4 months, you can get a pretty amazing capability. So, again, shoot us some data, and within 4 to 6 weeks, you might have something pretty remarkable.
Great, and I think the next question is sort of related to the first one. What special skills are needed on our team for such projects?
Yeah, so it's kind of varied. So in a lot of cases, we're showing some semantics capabilities in that, but the platform itself is actually designed for business analysts and domain experts. So once the ontology gets set up, and we have a number of customers that have really embraced and taken this on within either their IT organization or with a data scientist group, that they can sort of build their own, and they're showing us some pretty remarkable things on their own. But it's designed to being able to ingest data. It's a business analyst design. You don't need to learn Sparkle. You don't need to be heavy duty sort of technical person to do that. Once the data is in there, there's really very little that you need to know. There's a lot of capabilities that you need to learn about the platform, but if you know how to chart in Excel, you can do visualizations. If you're a domain expert with the data, then the dashboards and the slicing and dicing of the data to explore it and provide very interesting analytics is just nothing more than sort of showing what I showed in the filters. So very little from a new skill standpoint. There are some very sophisticated sort of ingestion and unstructured techniques that might need some specialized training, but we find that most of our customers get very proficient with the core platform.
All right. I think we have time to take one more last question, and like I said, all other questions will be answered if you had asked. And so this goes, the quality of the insight seems to be driven by the quality of the text analytic engines. How do you control the quality levels, for example, generating findings in the clinical trials?
Yeah, so I think what this question was relating to is on the unstructured piece on the text analytics, right? So what there are is that there are a couple of, the text analytics is looking for specific information within the document. So the quality of the engine is sort of looking for specific types of text in there. So I'll give you an example. So to find a drug name, right? So say you had a corpus of documents and there were drugs within that unstructured information, we would be able to find, sort of highlight what we suspect is a drug name, but what we typically do is look those drug names up into sort of an industry dictionary, right? So, we don't sort of invent it, it's not sort of invented from scratch, right? The industry has got a number of taxonomies, which we call sort of these data dictionaries, and so the quality of those sort of text analytics are augmented by these taxonomies. So if you use WHO drug or MedDrug, or any of these other sort of data dictionaries, or so that improves the quality of what you're doing. In some cases, though, there might be something of interest in you that you haven't seen before. So there's a couple of ways of doing that. You can set it up with a workflow to either manually curate that, sort of put that in a parking lot to say, hey, listen, I suspect this in this analytics, it looks like it's something of interest to me. I'm not quite sure what it is. Then you would actually have one of your, data stewards taking a look at that and says, yeah, this is what it is. And over time, you could refine that, right? You could expand your dictionary over time. You could go get those. So, in any case, the quality of the data, can make or break, kind of the insights to get in there. But what we can find is we can sort of look for those kinds of anomalies and sort of, clean the data. I think that's a key point within any one of these projects, is to sort of, make some assumptions that the data will not always be perfect, and that you need to have some mechanism to either refine the data or, push it off into a side, or at least make sure that if you're uncertain about what to do with it, that you, have some process to deal with it.
Great. We are almost out of time here. Thank you all for attending today's webinar. Like I said, the questions are still keep coming up, but we'll make sure to answer all the questions. The presentation will be available as a recording, and I'll send out a link to that. Thank you, and have a great day.